All right, today we are diving into something so basic, so fundamental that it makes up literally everything. Everything you see, everything you touch, and yep, even you. We are talking about the atom.
But right away, that brings up a really fascinating problem, doesn't it? I mean, atoms are impossibly small, totally invisible to us. So how in the world do you prove something exists when you can't even see it? For thousands of years, that was the big puzzle. And today, we're going to follow the clues that finally cracked the case.
Okay, so where do we even begin? Let's start with a really simple but kind of massive idea. Everything in the entire universe, from a distant star to the device you're watching this on right now, is made of the same fundamental building blocks.
To get your head around that, think of it like this. You know how just 26 letters can be arranged to create every single word in the English language? Or how a handful of ingredients can make a cake? It's the same idea. A limited set of atoms can combine in endless ways to build everything we see and touch. And what's really wild is that scientists have figured out there are only 118 different kinds of these basic ingredients, these atoms. We call them elements, and you've probably seen them all laid out nice and neat on the periodic table.
So where did this whole building blocks idea even come from? Well, to answer that, we have to go way back. I'm talking more than 2,000 years, long before science labs and experiments, back to a time of pure philosophical thought. Our story really kicks off with an ancient Greek philosopher, a guy named Democritus. He asked a pretty clever question. If you take something, say a rock, and keep cutting it in half, over and over again, can you do that forever? He argued, no way. Eventually, you'd have to hit a final, tiny particle that was so small and so strong it just couldn't be cut anymore. He called that thing atomos, which in Greek literally means uncuttable. But here's the catch. Democritus had zero proof. It was a brilliant idea, a great thought experiment, but without any real evidence, it was pretty easy for other big-name philosophers to just brush it aside. And so, for over 2,000 years, the atom was just, well, it was just an idea, waiting in the wings for some proof. Now, let's fast forward almost 2 millennia. The whole question of the atom moves from the philosopher's garden into the chemist's lab. And here, as scientists are mixing and measuring things, they start to notice these weird repeating patterns in how stuff reacts. You can really see how the pieces started to click into place. First, you have Democritus planting the seed of the idea. Then, centuries later in the 1700s, you have chemists like the Lavoisiers who identified elements, pure substances you couldn't break down anymore. But the real game-changing clue, that came in 1808, from an English schoolteacher named John Dalton. Dalton noticed something incredibly precise, almost magical. He saw that elements always combine in fixed whole number ratios. For instance, to make carbon monoxide, you need 1.33 grams of oxygen for every gram of carbon. But to make carbon dioxide, you need exactly double that amount, 2.66 grams. That wasn't just a coincidence, it was a secret rule of nature. So why would that happen? Dalton figured there was only one possible explanation for these clean, simple ratios. Matter must come in tiny individual packets, discrete, identical units that he called, you guessed it, atoms. It just made perfect sense. If one carbon atom grabs one oxygen atom and another grabs two, it explains those ratios perfectly. His early drawings, like these here, were really our first scientific look into this invisible world. Dalton's discovery was a huge leap forward, but, it was still indirect evidence. It was great for doing the math, but it didn't satisfy that deep-down human urge to actually see something with your own eyes, to really believe it. Which brings us to the ultimate challenge. After more than 2,000 years of just talking about them, was it finally possible to get visual proof? Could we actually take a picture of an atom? For a really long time, the answer was a flat no. And it all comes down to basic physics. A single atom is literally smaller than a wavelength of visible light. Trying to see an atom with a normal microscope is kind of like trying to measure a grain of sugar with a yardstick. The tool's just too big and clumsy for the job. The big breakthrough finally happened in the 1970s with an incredible invention called the Scanning Tunneling Microscope, or STM. Now, this thing doesn't see with light at all. Instead, imagine it has this incredibly sharp needle. We're talking a tip that's practically a single atom wide, and it hovers just over a surface. It can then feel the bumps of each individual atom, kind of like reading Braille, by measuring a tiny electrical current. And this is what it found. This is not a drawing, it's not a computer simulation.
This is a real image, built from that data. Each one of those little bumps is a single silicon atom, all lined up in a perfect grid. After more than 2,000 years, the debate was finally over. We could see them. Atoms are absolutely real.
So we found them. Case closed, right? Well, not so fast. Science never really stops asking questions. And the next obvious question was Democritus actually right? Was the atom truly uncuttable? Turns out the rabbit hole goes even deeper.
We discovered the atom wasn't a solid little ball at all. It's actually more like a tiny solar system. At the very center, there's this super dense core called the nucleus, which is made of protons and neutrons. Then you have these even smaller particles called electrons whizzing around the outside. But here's the most mind-blowing part. An atom is almost entirely empty space.
So, what makes all those 118 different elements different from each other? It is shockingly simple. What makes a carbon atom different from an oxygen atom is just the number of particles inside it. A carbon atom has 6 protons, an oxygen atom has 8. That one number defines its entire identity. That's it. And once we understood that structure, it just opened up this whole new reality. It led to some truly mind-bending possibilities that completely challenge how we think about the world around us. See, this discovery gave us incredible power. Could we change one element into another? Yes, absolutely. That's exactly what nuclear fission and fusion do. We can split big atoms or smash small ones together to make totally new elements. But could we destroy an atom completely? Amazingly, the answer is also yes. If an atom ever meets its exact opposite, its antimatter twin, they both just vanish in a flash of pure energy. Democritus's uncuttable particle could actually be completely erased.
So this whole journey has taken us from a philosopher's guess to actually seeing individual atoms, and finally to learning how to change them and even wipe them from existence. And it leaves us with one last really deep question. If the very building blocks of our reality aren't permanent, if they can be created and destroyed, what does that make us, who are made of that very same stuff?